move this away. Can you,
Yes.
everybody see? Okay. So thank you very much for attending this. So I'm the CSO for Sumifru. I've been with the company almost 15 years now, and it's never fails to interest me. As you know, this is we're in an industry that's very dynamic, actually. So let me introduce a little bit about the company. Okay. Okay, so Sumifru is really one of the biggest producer and exporter of fresh bananas. And this is our mission statement, and that's that we aim to excite the world with Sumifru bananas. And one of the core things for us is to be the most trusted and best provider of fresh fruit, in especially particularly in banana. We are 90% of our business is in the production and delivery of bananas to the consumer. We have about 10,000 hectares in the Philippines and another 2,000 hectares of our farm in Ecuador. So we ship from both Asia and Latin America. And one of the key of our mission statements is we constantly try to improve on our product and how we grow it, and how we deliver it to consumers. Okay. So this is the whole value chain that is what Sumifru does. So we actually have the entire value chain and supply chain from seed to shelf. So that starts from we have a good record of gene bank registry. We do a lot of research into cultivars and varieties of bananas, and from there we have our own tissue culture lab, in our own nursery, bringing the seedlings to the farm. We own the entire process from production, harvest, packing plant, into the logistics, before it gets shipped and exported to various countries. And we also do the end ripening before it goes to distribution. So basically, we have the entire supply chain from the start to the supermarket shelf. Okay, so in today's presentation, I have two of my colleagues, and we aim to provide three problem statements that are actually in part of this value chain. So we will have one that is very relatable, that's very relevant to the farm in the production. In terms of soil resilience, we will have one in the packing plant, which is the post-harvest operations, which is also a huge factor in the entire supply chain and value chain. And the last one is the one in the markets, which is the entire ripening process. Okay. So as I speak, so we have three of these challenges. So challenge one is from the farm, and our presenter will be our Head of Business and Research Innovation Department. Jillian will speak a little bit more about the challenges we face with regards to making sure that the plants get the right nutrition at the right time, and how to make our farms more resilient. We are primarily in banana. That also means that we are fairly monocrop. Okay. In challenge two, Charmaine Sensano, ahead of our fruit processing innovation, engineering and packaging, she will talk a little bit about the post operations and the challenges we face with regards to the use of water. We would love to recycle water as much as we can, reduce our usage of water as a whole in the entire post-harvest operations, and she will speak more to that as to what we have done and the challenges that we still continue to face. For challenge three, unfortunately, everyone has to bear with me because my engineer was not able to make it at the last minute, but we are talking about the ripening rooms that we have, where we ripen the bananas and get it ready for delivery. But it is still a fairly manual process, and we would like to talk about how we can better automate that, and as well as better assess the banana quality before we ship it to the supermarkets.
Okay, hello, good afternoon, everyone. Okay, please proceed to the next slide, Angela. Okay, so as mentioned, our problem statement is really on how to improve the nutrient absorption, efficiency, and the soil resilience. So in growing bananas, soil has always been part of the major drivers for our productivity. So being the medium for our growing, we believe that understanding the soil and what it can give and optimizing it will ensure that we're giving the plant the maximum potential for its yield. So in this regard, soil fertility and plant nutrition always go hand in hand in our initiatives and our innovation steps. Um, then next slide, please. So yes. Okay. And in the past 4 decades that we have been watching the climate change, we have experienced more than 30 episodes of La Nina and El Nino. And only in the from 2000s, we already had an average of zero point 0.8 increase in the temperature, global temperature. So more than ever, we are experiencing the harsh impact of this erratic weather conditions, and that affects our banana. So with this, we have focused on producing like an all-weather banana that will not only withstand this erratic weather conditions, but it can also still reach its potential and the best quality for the banana. Next slide, please. So in conventional banana growing, the reliance on synthetic fertilizer has always been a constant, and it's a standard practice wherein the amount of fertilizers that you have to put in will have to include buffer, and this is not only to anticipate losses through volatilization or through leaching, but also to address the non-uniformity or the high variability of each plant that you are fertilizing. So, thus, every buffer or every allowance that we have to make in putting or in applying in our soil, it becomes a waste for us. Thus, this problem statement. Angela?
Okay, thank you, Jillian.
All right. Thank you, Angela and Jillian and Shami. Very detailed presentations. So I think we already have 4 questions in the chat. So without further ado, let's settle the questions for challenge 1 first. So Nisha is asking, in regard to the first challenge statement, the erratic weather is referring to the Mindanao location in the Philippines. Could you share more about the current fertilization regime and how many times fertilization is repeated during the unpredictable weather patterns?
Okay, so the erratic weather conditions is not only localized in Mindanao, but all over the Philippines, we are experiencing that. And then for the current fertilization regime, um, we are using on the average around 5 to 6 different products or synthetic fertilizers, and the cycles or the number of times that we apply this vary per product. But in total, there would be an easy 30 cycles in a year, depending on what product to be used. And during the way it's programmed is we do know the months that are not favorable in terms of application. So in those conditions, we decide or we choose not to apply. Then, okay, yeah,
All right.
that's it.
So the other question pertaining to this challenge from Anya is, do you have any target metrics? For example, what is the dollar value of fertilizer buffer that you are looking to save? And I think a corollary to this question is, how would you be measuring something like, like the difference in soil resilience after the solution has been implemented, um, and like the nutrient uptake efficiency over time, etc. So do you have a plan on how that needs to be measured?
It's easily quantifiable because it's easily associated with the yield that we have. But on the cost side, or just purely on the spending side, I believe that a target of reduction of 50% on the cost would be a reasonable target.
All right.
Maybe to help Jillian out a little bit, because before I did the sustainability job, I did the finance job. So let me explain. I think but what you mentioned is yield first. For us, it's yield first at the same cost level. When we talk about efficient nutrition, we are really talking about yield first. The yield has to come first. There's no point reducing cost and then not getting the yield that we want. So that always comes first. And then with that, then we look at, how much dollar value that we are able to save in fertilizer.
Right. Understood.